Welcome everyone to this incredibly fun explainer. Today, we are using NASA's absolute latest data to demystify the universe's biggest, most fascinating cosmic beasts, black holes. So if you've ever looked up at the night sky and wondered about the invisible forces shaping our entire galaxy, well, you are definitely in the right place. But hey, before we get into all the heavy science, I want you to picture something totally mind-bending. What would actually happen to Earth, and our entire solar system for that matter, if we instantly replaced our sun with a black hole of the exact same mass? It's a crazy thought experiment, but we are going to answer that exact question before the end of this explainer, and NASA's answer might actually shock you. Okay, let's dive into this. Here is our roadmap for today. 1. Anatomy of a black hole. 2. Seeing the invisible. 3. Fact versus science fiction. And 4. Cosmic record breakers. We're going to break this massive mystery right down into clear, logical pieces. All right, kicking things off with Section 1, Anatomy of a Black Hole, the basics. Now, right at the core of a black hole's anatomy is something called the event horizon. Basically, it's the boundary where gravity becomes so incredibly intense that the required escape velocity actually exceeds the speed of light. And it is absolutely crucial to grasp that this isn't a physical, tangible surface like the ground we walk on here on Earth. No, it is a strict mathematical cosmic boundary. Once you cross it, that's it. You are completely at the mercy of the black hole's gravity. And this actually brings us to a really major misconception. Black holes are not just empty voids in space. The name black hole is actually a bit of a misnomer. According to NASA, they are massive concentrations of matter packed down into unimaginably tiny, dense spaces. It's this extreme, mind-boggling density that creates that intense gravitational pull we always hear about. 4 million. And this brilliantly illustrates exactly what we're talking about here. 4 million is how many times our own sun's mass would need to be multiplied to equal Sagittarius A star, which is the supermassive black hole sitting right in the center of our very own Milky Way galaxy. Even though it's crammed into a relatively small area of space, its mass is just almost too vast to even comprehend. So, moving right along to Section 2, Seeing the Invisible, the detective work. This is the big question, right? If black holes don't emit or reflect any light whatsoever, how in the world do scientists actually find them? Well, it's brilliant detective work. Step 1 is spotting X-rays from superheated, glowing accretion disks swirling around them. Step 2, track the erratic orbits of nearby stars. Astronomers actually proved our own Sagittarius A star exists by doing exactly this, and they won the 2020 Nobel Prize for it. Step 3 is catching gravitational waves, which are literal ripples in space-time. And finally, Step 4, gravitational lensing. This is where scientists look for how extreme mass actually bends the light of galaxies sitting far, far behind the black hole. It's like looking through a funhouse mirror. All right, let's shift gears for Section 3, Fact versus Science Fiction, Busting Myths. Now, what's really interesting about this slide is how much Hollywood loves to get it wrong. Movies constantly portray black holes as these magical wormhole portals to other dimensions, or like terrifying cosmic vacuum cleaners just roaming around eating planets. But NASA's hard science confirms they absolutely do not provide spatial shortcuts, and they definitely don't quote-unquote suck things up. If you are far enough away, a black hole's distant gravity behaves exactly like the gravity of any normal object in space of the same mass. Okay, let's really ramp up the enthusiasm for our final act here, Section 4, Cosmic Record Breakers, Mind-Blowing Facts. 66 billion, the most massive black hole ever observed. TON 618 tips the cosmic scales at a terrifying 66 billion solar masses. Let that sink in for a second. When you consider our galaxy's monster is only 4 million solar masses, the sheer scale of TON 618 literally induces cosmic vertigo. It's just unbelievable. But check this out. On the exact opposite end of the spectrum, we have 3.8. The absolute lightest known black hole ever found is only 3.8 times the mass of our sun. It actually exists locked in a binary pair with a regular star. It really highlights the incredible sweeping diversity of these cosmic objects. But seriously, what actually happens if you get too close to one? Well, spaghettification. I know, it sounds like a complete joke, right? But it's a very real astrophysics term describing extreme tidal forces. Basically, when matter approaches a black hole, the gravitational pull is intensely stronger on the side closer to the hole. So the matter gets squeezed horizontally and stretched vertically into a noodle shape. Literally, if you fell in, you would be stretched out into a localized stream of subatomic particles. Not exactly a fun weekend trip. 1,000. You see, almost all black holes actually spin, but the fastest one ever recorded clocks in at over an astonishing 1,000 rotations per second. Think about that. Imagine an object with the mass of an entire star spinning so incredibly fast that it literally drags the very fabric of space-time around with it. Let's rapid-fire some more amazing cosmic trivia to round this out. Many black holes are born in supernova, which are just massive star booms. Monster black holes at galactic centers can act as immense particle accelerators. The closest one to Earth we know of, Gaia BH1, sits about 1,500 light-years away. And the farthest one we've ever detected? It resides at the center of a galaxy a staggering 13 billion light-years away. It just shows how beautifully chaotic our universe really is. Which brings us circling right back to our opening hook, the big thought experiment. If you replaced our sun with a black hole of the exact same mass, what happens? Well, the planets would stay in their orbits perfectly. No way, right? But it's true. Because the central mass hasn't changed at all, the gravitational pull remains identical. Earth would just keep spinning right along on its path. However, without the sun's radiation, our solar system would instantly freeze. So the big takeaway here? A black hole's gravity isn't uniquely dangerous as long as you just keep your distance. So, while we've mapped out their borders and measured their mass, one incredibly profound mystery still lingers. What does matter actually look like once it crosses inside the event horizon? The truth is, even NASA's best mathematical models completely break down at the singularity. It remains one of the ultimate enigmas of modern astrophysics. So, what do you think? Will we ever crack the code of what happens deep inside? I guess that's up to the next generation of space detectives. Thanks so much for joining me on this explainer, and keep looking up.